Our next speaker for today is Professor Marcel Stive, who is currently Emeritus Professor of Coastal Engineering in Delft University of Technology in the Netherlands. He has over 40 years of worldwide experience in research and consultancy projects in the field of hydraulic engineering, coastal morphodynamics, coastal biogeomorphology, and coastal and estuary management. He is also the inventor of Sand Engine in the Netherlands. Let us now welcome Professor Marcel Stive to share about the Mekong Deltaic coastal processes with a focus on mangroves. Prof. Marcel, please.
Thank you very much for your enthusiastic introduction. We're all delighted. And we're very proud to have been invited to advise the most perfect city-state on the world. I mean that. If people ask, what are you doing? The first thing I say, I advise Singapore. So it's really a pleasure for us to be here. I'd like to talk with you about mangrove. My inspiration are the mangrove in the Mekong Delta in Vietnam. And I've done this work not on my own at all. Here are, I think, 4 of my PhDs that all looked at mangrove issues. And I'm proud to present some of the work. We have only 20 minutes. We could talk about this topic for hours. So I'll skip some things. And I hope you forgive me. So, the topics are that I'd like to talk to you about land use changes. And Jane already mentioned it, coastal squeeze. That's one of the big issues for the health of mangrove. And I'll show you some nice examples. I'll shortly talk about coastal erosion. That's a little complex in the Mekong Delta, but yeah, we looked at that. I'll say a few things about it. And then, of course, there's damping of waves and currents in mangroves. That's why we think they are useful as a protection. I will not say much about wave damping. There's a lot of that stuff in literature, but there's very little in literature about current damping. And I'd like to show you some very interesting results. And then there's some remaining issues that we should consider. So let's start with squeeze. The squeeze of coasts has been a problem for, well, I would say at least 50 years. And it is because the value of coasts was rising very much once people started to understand it was not just a base for fishermen, but it was an attractive place to have recreation. And so we, in Europe, we built like crazy hotels close to the coastline, and we had loads of coastal squeeze. And you can see in Asia, in countries like Vietnam, it's happening. So let's have a look at another reason behind coastal and estuarine squeeze for coasts that have mangrove. This map tries to illustrate that the increase of aquaculture in the Mekong Delta has risen very strongly, and it has gone to the cost of the mangrove systems. And aquaculture is one of the reasons of the strong coastal and estuarine squeeze that we have. And so if you look at land use changes, there's a lot of information here, but concentrate on this color over here. That is all conversion of mangroves into aquaculture. And the purple ones is converse of land use into aquaculture. So it's not going to the cost of mangrove, but aquaculture is very important there. Aquaculture has a lot of consequences for instance, for subsidence, groundwater extraction, etc., etc. But let's go to the coastal squeeze issue. Now, imagine this is a cartoon, you could say, of the delta of the Mekong. By the way, also in the north of Vietnam, you have these systems, and people have been building dikes to protect land that has been considered as useful. And I mean, one of the big wishes of the Vietnamese government was, we want a dike along the whole coast. And we put a big road on it, and we go as close to the sea as we can. And so there are lots of issues with the dikes. But I want to concentrate on one particular issue, and that is that what happened is that a lot of aquaculture has been placed just outside the dikes and taken away the mangroves that are there. Some of you may have seen it, and all of a sudden you see something like a swimming pool. You think a swimming pool? Yeah, it's a swimming pool for shrimp. And it means basically in those very high yield aquaculture systems, they take away all the mangrove to have it available for shrimp culture. So what basically happens is that the space that the mangrove had is being reduced. Now, I had one of my PhDs looking at investigating the hypothesis that if sediment availability is not an issue, so suppose there's enough sediment to feed the mangrove systems to stay healthy. How much space do you need for the mangrove system to be able to stay healthy? And so here's a plot where this is cross-shore distance, and these data indicate the space available in the cross-shore and whether or not there is erosion or accretion. And it turns out that there where sediment availability is no issue, this is an important part of what we research here. How much space do you need for the mangrove to stay healthy? And yeah, we think the data of the Mekong Delta indicates something like 300 meters for the coastal system. And what area did we look at? Not here. This is the highly eroding Kamau area. Very interesting. I can talk half an hour about that, but we will not. But here are what now is the 6 dragons, they call them, and it used to be 7. And the dragons are the estuarine arms of the mighty Mekong River. And there, in this area, the river is still feeding the coast with sediments. So we're looking here at an area where sediment availability is still not an issue. And well, you understand what I would promote in Vietnam and say, please leave some space for the mangrove to thrive. Use 300 meters at least on the coastal system. What's new is I asked another PhD to look at estuarine mangrove squeeze. So especially the salty part of the estuary, that is where mangrove can compete with other vegetation. So that there are mangroves there, and of course the composition is different. Also the physical situation is slightly different because this is the river bank, and here you have the deeper channel. By the way, the channels get deeper and deeper because there's a lot of sediment taken from the system, but that's aside. And basically you have the same problem. The farmers look for space and they move towards the river banks and they squeeze the mangrove system. And well, you only have to go to the internet and look at satellite pictures. here you see the 2000. This is along an estuary, so it's not along the coast. So there's flow here in the river system, and this is the bank, and this is the fish farm situation in 2006, and these farmers wanted to have a bit more, right? Now you only have to look here in front of those fish farms, and you see that within 4 years there's a lot of damage done to the system. And so we did the same exercise there, and we came to the conclusion that you need a bit less space in the estuary, say 200 meters, to have healthy mangrove. And well, that makes sort of a bit of physical sense, because the coast is more violent, say, with waves with it. Here it's only flow. If for the coast, we did a lot of research also, like a lot of research is done on this topic of the damping of waves in mangroves, and we came to the conclusion that through modeling, that to have effective damping of waves in mangrove systems, you need between 3 and 6 wavelengths to dampen the waves, depending on the density of the vegetation. And if you think about 300 meters, well, take a 2.5 meter high tide plus surge, waves of 5 seconds, and 5 times the wavelength brings you around 300 meters. So that makes sense in a physical way. So the conclusion that we draw is that this is of course crucial, that if there is sediment availability, you need that space. And maybe those of you that were with us looking at the mangrove area, you remember in front of the building, that there where there was more space, also the mangrove could survive better, and they were extending more compared to the regions where that is not the case. On coastal erosion, of course, outside the regions where it's also there's no sediment availability, that also you get impacts of gradients in longshore transport, and there are a number of very interesting phenomena in specifically in the Mekong, which I'll not be able to talk about. But what I love to talk about is current damping. I told you a little bit already about wave damping, but there's so much literature. I don't need to explain that to you. You can look that up yourself, but I'd love to tell you about current damping. We didn't do it in the field yet, which is one of our wishes. We are trying to establish a living lab in a mangrove area, because these systems are very difficult to just study by modeling and in the lab. They're pretty complex, and we don't understand the complexity yet. But here you see, for instance, a lovely example that the fish farms are coming closer, and yeah, there's waves coming in, there's currents. But let's now concentrate on the currents. Now here's an interesting experiment. This is in the laboratory. So the channel is over. So these are 3 situations. So 3 shots of a situation in which the mangrove have more space and less space and lesser space. So the bank width is reduced, going from here to here. And this is taken off the experiment, right? I hope it's clear to you. So you must imagine that the mangrove here have space, here they have less space, and here they have minimum space. And if you look here at the die, which of course is illustrating the current, you see that you have vortices, horizontal vortices that penetrate into your bag with mangrove. And of course, we started to measure it. Sorry, here it is the other way around. Here's now the channel, and here is the bank, and here you see these horizontal circulation cells. So if there's enough space, the flow injects material, sediment, and nutrients into your mangrove system. And you can imagine if this space isn't there, it doesn't happen. And so that is the explanation that you need some like maybe 200 meters of space for this mechanism to be effective. And here's a picture. So here's the cross section. You see. So this is a real picture, right? Satellite picture. And so here we have the bed of the main river. This is actually taken in the Mekong Delta, one of the estuarine arms. Here are the mangroves. And here are the mangroves that are still there in the floodplain area. And here you see in the sediments, they reveal those large horizontal circulation patterns. So here there is hopefully still enough exchange between the channel and the floodplain. And here you see the projection of the calculations that my PhD could fit under here. And so I'm coming to closure now. I was told I'm going to see 10 minutes, 5 minutes, 1 minute. I don't see anything. Where is it? Oh, there. I can't see you. No, sorry, I'll be quick. Remaining issues. Yeah, what have we? We have, of course, the interesting topic of what do the Chinese do up in the Mekong? And of course, I mean, that whole river has lots of dams. But if you do research on this, it'll take a long, long time before those dams will really affect the sediment transport. Because very soon after the dam, the water still flows, and it'll pick up sediments. And of course, it's lovely to say, it's my neighbors that do it, and it may work effectively to get funding, but basically, I don't think it's one of the biggest issues yet. Maybe in 50, 100 years, but at this moment, that's not really that important. What's important is subsidence and sediment extraction in the country itself. And don't forget pollution of agriculture. There's a lot of pesticides that are released from those farms. And if you go to subsidence, the substance here at Kamau here is more than 2 centimeters per year. And I love showing this picture. We're driving here in the Mekong Delta, right? And the road system is about, say, the beginning of this century. So a little over 20 years in age. And of course, the bridges are founded in the underground, but the roads themselves are not. It's just an earthen dam. And if you look at all the bridges, although on these roads they say you can drive 100 kilometers per hour, I advise you not to do that at the bridges. Because what happens is you see about 20, 30 centimeters of a little steep transition between the bridge and the road. And so basically you can observe from the roads that there is more than a centimeter subsidence per year. And that's going to be an issue if it's not stopped. If they don't follow, like Robert shows, they have to stop taking fresh water from the underground. And then here is, Robert mentioned as well. I mean, these are the figures. This is in tons of sediment per year. So this is what they extract from the river itself. So any sediment that might still be coming from Cambodia will first settle here before it will settle outside. And so are there solutions? Jane talked about that. The Chinese do this already for 5 to 10 years. This is in the Yangtze. This is that huge defecation channel. And they use the material to create higher, more elevated spaces of, I think I see 0 minutes, right? I'm there, don't worry. And so they're already experimenting for quite a long time with both bringing in sediment and of course using simple methods that can be taken away to promote sedimentation. We think that this is one of the nature-based solutions that may work also for mangrove. And of course, you can also try to think that if you want aquaculture integrated in the mangrove systems, preferably use extensive farming and not intensive farming. I mean, there's no mangrove in here at all. And of course, mangrove can have a very purifying role into aquaculture. And so I know there's a lot of experiments going on there. And I'm curious to see if that might happen. But this is just a summary of what I said. Thank you.